Welcome everyone. Now we are going to see list of experiments in Nuvoton board. The basic Nuvoton board consists of 5 ports of GPIO pins: GPA, GPB, GPC, GPD, GPE. In port A, I2C protocol pins are there. In port C, SPI1, in port D, SPI2 and CAN lines. There are 3 PWM signals and RGB LEDs attached to port A. There are 4 LEDs which are connected to port C and a switch is connected to port B. The RGB LED connections are red GPA12, green GPA13, blue GPA14. Board LED connections are GPC12, GPC13, GPC14, GPC15. The board switch which can be configured to input is given as GPB15. The buzzer at the left corner is given with the GPB11. Coming to the code, we are using a software for coding is Keil. Language used is C. For compilation, we create the Keil file, hex file from the Keil software and load the hex file to NUV-ICP, a program software. It's a option APROM to put the hex file there and uncheck the config option and burn. The first program is blinking of LED. Initially, we set the pin as output in the specific command and give low value to the pin. After few delay, we make the pin value high and give some delay. This is the basic blinking LED is a basic program. Let's walk through it. This is a header file drv gpio.h. We initialize the pin as output pin drv gpio open brackets e underscore gpc 12 eio output. We specify output so that the pin becomes output pin. We give the value making the pin high. Here the negative logic, high is negative, 0 is high and 1 is low because negative logic. The delay counter gives a delay. While delay it is high and next cycle it is low. The LED is connected to pin 12 of port C will blink in an equal interval of time as specified before 12 here. Let's go to the output. See, the 12th pin LED is blinking. Okay, the next experiment is blinking of LED in a pattern. Make the pin as output by using a specific command. Make the first LED to glow by moving the value 0 to the pin. Give a delay and make the next LED glow and the first LED to be off. Repeat the same steps for all LEDs and make a loop to step 2 as a cyclic process which will result in a blinking of LEDs in a pattern. Coming to the code, include drv gpio.h. It's a header file, it is required. We make the pins for LEDs GPC 12, 13, 14, 15 as output pins. We have made it. Now while one forms an infinite loop, initially we take the 15th pin low and 12th pin to be on. We add a delay counter and a while loop until this occurs. Next we make 12th pin low and 13th pin high. We add a delay and then 13th pin low and 14th pin high and we add another delay until this while loop that cycle occurs. Next we add 14 low and 15 high. The delay counter adds a delay again here. It's a recursive loop. Let's see the output. Based on the delay value we give, the LED pattern has the delay. Okay, next let's go to the third. Accessing RGB LEDs. Make the pin as output by using a specific command. Move different values in the pin which is connected to the RGB LED. Call a function in which general purpose LED should blink 10 times. Move next set of values in RGB pins and repeat step 3, which forms a recursive loop. Coming to the code, we declare GPC 12, GPA 12, GPA 13, GPA 14 as output pins. We form an infinite loop here using the while one. The GPA 12 goes to the RGB. Initially it is 0, hence it is high. GPA 12, which represents red, we make a normal LED blink 10 times. This is a function, count is a function which will be followed below. Now in the second, GPA 12 is 1, GPA 13 is 0, GPA 14 is 1. So now we are making GPA 13 high. GPA 13 represents green color of the RGB. The third cycle, we have GPA 12 as 1, GPA 13 as 1, GPA 14 as 0. Hence GPA 14 is blue, the RGB blue color comes up. We have the infinite loop for normal LED to glow. For I equal to 0, I is less than 10, I plus plus. Sorry, not infinite loop, it's a less than 10. So 10 times. GPC 12, which is a breadboard LED which will blink at the right side. We have a delay so that high, low, it will blink. Let's see the output. See, the RGB is glowing and the LED over here is also glowing. This color changes as the delay we have specified in the command. Let's go to the final program. LED controlled by switch. Initially, make the pin B15 as an input and LED pins and buzzer pin as output by a specific command. Make one LED on and another off state. Check for the button, press in port B, pin 15. If the button is pressed, toggle condition of LED and buzzer. Repeat step 3. Let's go to the code. Program includes initially configuring input and output pins, GPB15, which is the board pin which has a told earlier, which can be configured as an input. GPC 12, 13 and 11 are output pins. We form an infinite loop by giving while 1. GPC 12, 0 makes the pin high, breadboard LED 1. 13, 1 makes the LED low. If we press the button, that is if GPB 15, if we press the button, GPB 11 equal to GPB 11, toggle the value, means if it is high it will go low, if it is low it will go high. GPC 12 equal to 1, we make breadboard LED 1 to go down and LED 2 to go up. GPB 11 is our buzzer, it will go high. Initially we have substituted as 0, if we press the button it will go high. The output